Let's continue problem 31. I will skip it because it's exactly like the previous problem 33. So try it, and if you cannot do it, let me know and I will do it the next time. So because I want to continue to something new. So and then I go to problem now 45, which is what we have here, and why this here is interesting, is because this is the x and y axis. Okay, this with black. So and we have here is the graph of y is equal with x squared, and this is the graph of y. The red one is the graph of y is equal with 1. So what is the new thing here is that we want to find the volume of the solid that is created when we rotate this area here, which is bounded by the x-axis, the blue line and the red line. So when we rotate this area around, now what? Around the axis y is equal with -1. So it's not anymore with respect to x-axis or y-axis. It's with respect to some other, which of course is either parallel with the x-axis or parallel with the y-axis. So in this case, it's parallel with the y-axis, and create this. When you rotate this, you create the solid, and we want to find the volume of the solid. So let's do it. So the volume V it will be equal with. Okay, it's the same principle. It's the washer method, but now, like the radius, if we were rotating with respect to the y-axis, the radius it will be, for the red line, it will be from the red line to the y-axis. In this case, the radius that you are rotating, it's from the red line to the green line. So that means, of course, it's pi. We put the let's put here dy, since we're rotating with respect to an axis parallel with the y-axis. So again, we have y, and of course, if you rotate with an axis which is parallel with the x-axis, you should have x. So we put the limits later, but now let's see. So we said that the radius that we're rotating, it's this here. So what is this radius here? It's this line here, which is 1, minus this line here, which is minus the -1. So that should be your first function square. And now the second, it should be minus, because we rotate this and then we rotate the blue line, so we have to subtract this. It's again a washer method, but it's with respect now again with green line. So now the radius, it's the distance from, let's say, this point to this point. So this point here, it's the it's the y is equal with x squared, but because we have here to find the integral with respect to y, we have to make this here equal. We have to find it with respect to y, so that means we have to take the square root. So that means that x is equal with square root of y. So this is the distance from the line here, which is x equal with y. x is equal to square root of y, sorry, minus, this line here, which of course, again, is the minus 1. Of course, this is squared. And now, we have to find the limits. So here we're integrating from from this point to this point. Okay, so that means this point here has, in the y axis, with respect to y, it has y coordinate 0. And this here, if you if you solve the two equations, it has also y is equal with 1. Okay, so we find the upper limit here is 1. This is pretty easy if you just substitute whatever y1 here. That's the point of intersection. So that's the limits. And now let's see how much is this. So this will be equal with pi. And now this is minus the minus 1 minus 1. So that's 2. 2 squared is 4. And here you have, let's write it here. So that's the square root of y plus 1 square. So that's d squared. So that's square root of y squared, which is y, plus 2 square root of y times 1 plus 1 squared, so plus 1. So then of course all this has to be with respect to dy, I write it here. So that's equal with, and of course the limits is from 0 to 1. From 0 to 1, that's 4. We remove the brackets, what do we have? We have minus y, minus 2 square root of y, minus 1 dy. Now this will give us pi 0, 1. No, this 4 with 1 gives us 3. So that's 3 minus y minus 2 square root of y, and that will give us, this is always with respect to y, so the integral of this, it will be, the integral of 3 with respect to y is 3y, the integral of y, it's y squared over 2, and the integral of this here, it's minus 2, so this is square root of y or y to the 1/2. So the integral of this is y to the 3/2 over 3/2. So that means that the 2 goes here and the 3 goes here. And of course this has to be integrated from 0 to 1. Let's do it. So this is pi. Now we substitute the first time the upper limit 1. So that should be 3 minus 1/2 minus 4/3. And the second time you have to substitute a 0. If you substitute 0, will give you 0. So the only thing which is left is this here. So that's pi. Now the least common multiple is 6. 6 times 3 is 18. Minus 3 minus 8 over the 6, which is the least common multiple. So that will give us 18 minus 8, 10, minus 3, 7. So the final answer is 7 pi over 6, which of course agrees with the solution that we have at the end of the book.